Hello, and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about a surprising case of a very large integer causing a sequential scan in Postgres. So this blog post by Jeremy Evans, who is the author of the SQL library for Ruby, talks about how when you pass in an integer that is larger than 64-bit, Postgres suddenly decides not to use an index and instead uses sequential scan. When you're passing an integer inside a SQL query, and that integer is larger than the size of the big int type in Postgres, then Postgres treats that value as a numeric value because big int would not fit. So far, so good. Now, the problem is when Postgres makes a comparison between a big int value and the numeric value, Postgres will cast the big int value to numeric because it doesn't know if the numeric fits into integer or big int. Instead of casting that one to the big int, it will actually cast the column you're comparing with to be numeric and then do a comparison. The effective problem that creates is when you have an integer or big int column in your table, for example, that column is named ID, and you have a regular index on the ID column, and you issue a SQL query that says select star from table where ID equals a very large number, then Postgres will not use any index on a table because the index is on that particular column being a big int, and it couldn't use it with a numeric. This might seem like an edge case, but we'll get to a very real world situation in a moment. Jeremy illustrates this by using a generate series function. It's always a great tool to have in your tool belt for creating test data. And then he just runs an explain analyze on the data. He doesn't just use an empty table, because if you used an empty table, you would of course get a sequential scan because that's going to be faster. But this is not what's happening here. First, he uses something that is just inside the big int range, one less than the maximum size. And then he uses one that is exactly outside of the range, which is +1. The number that is inside the big int range uses an index-only scan. This was very fast, like 0.1 milliseconds. Now he runs another query, and here he has the larger number. And this does a parallel sequential scan, so it scans the whole table to then be able to filter by casting this to numeric and then doing a numeric comparison. This has performance that's over 1,000 times worse. But this is still a pretty small table. So imagine this on a use case where you have tens or even hundreds of gigabytes of data that gets scanned in the sequential scan. This could be a huge problem. And as Jeremy mentions, this could also be a potential denial of service vector. Now, how can you mitigate this problem? One way of solving this is what Jeremy calls here bound variables or bind parameters. Instead of having Postgres do the conversion on the server side, you're explicitly telling Postgres and passing you a big int. And if something doesn't fit into the big int, you raise an exception. You could do an explicit cast. So here, for example, you can just cast your number as you're passing it in to an integer. And then if it was too large, Postgres would just complain and not do that sequential scan. Oftentimes that's challenging though, as Jeremy points out here, because if you have an ORM, like the one Jeremy himself writes, it's actually hard to have this kind of behavior in the ORM because there are certain cases where you want to have that implicit casting behavior. From an ORM perspective, Jeremy addressed this in two ways. First of all, he changed the SQL ORM in Ruby to explicitly check the sizes. So this prevents bad data being passed in. The second thing that Jeremy has done is to switch to using bind parameters. And in SQL, that's a choice. You have to use this PG auto parameterize extension. But this is something that I would recommend you take a look at when you're using SQL, because it will help you prevent these type of problems in the future. Now, you may think that a lot of ORMs already use bind parameters, but unfortunately, that is not necessarily the case. It definitely helps to double check whether your ORM directly uses values in your queries or uses them as bind parameters. This might seem like an edge case. Is it actually a problem? The team at Reddit also uses Postgres, and they described a case where many years ago, they had a case where in the URL, you would have IDs, and these IDs were base46 encoded, and then they would translate them back into an integer and then look them up in the database. They would have bots coming in, and they would just use some random strings, and they become very, very large integers. They were running into this exact problem on their production site with Reddit. They were getting a sequential scan. It takes a long time, eats your disk bandwidth, all these problems. Their fix was, of course, the simple validation that they should have been doing the whole time. But again, this was a surprising behavior. It was surprising why Postgres didn't handle that for them. And in their case, for example, they were using the SQLAlchemy ORM in Python. So be careful with this. This can be an actual real world problem if you have user supplied data that then is directly used in an integer type comparison. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to the YouTube channel to hear about next week's episode, and talk to you next week.